So you can find me on Twitter at Ajebo Developer and on GitHub at Sammy820. Don't go to my GitHub. Python has really come a long way from where we started, because although professionally I've been in Python for about 2 years now, but when I initially discovered Python, it was about 2011, 2012, and I got discouraged a lot. Because by that time, I'll be like, okay, what are you doing? I'll be like, okay, I'm doing Python, and this is the look I usually got. They're like, what is that? Like, are you not doing Java? Are you not doing C#? Are you not doing all those things? But recently, with the advancement in machine learning and AI, you see a lot of Python devs feeling themselves. Now, you see a lot of Python devs acting like this. So, I even met with one of my friends yesterday, and he was like, I'm a data scientist. As in, even the confidence he used to say it, I was like, damn. I was like, this guy is confident now. So, what is GraphQL? I Googled this, and this is what I got. At its core, GraphQL enables declarative data fetching, where a client can specify exactly what data it needs from an API. Instead of multiple endpoints that return fixed data structures, a GraphQL server only exposes a single endpoint and responds with precisely the data a client asks for. Wow, that was a mouthful. Basically, what that definition was trying to say is that we have one endpoint. And we front-end, okay, I was even supposed to run a survey. How many of us are front-end developers here? Okay, thank you. How many of us are back-end developers? How many of us are full-stack developers? See there, see there. So you're not raising your hand for front-end, but you're full-stack developers. Okay. So basically what GraphQL does is that for every client, you can actually declaratively ask for what you need from the server, not just waiting for a particular endpoint based on your API documentations. What problem did Facebook see before they decided to implement the GraphQL technology? I took this quote from CodeBeast from his concatenate conf, from the concatenate conf where he talked about GraphQL, and he said, it should be about what the client needs, not what the architect thinks that the client would need. Because that's basically how it is when we are building our backend services. Because for a while, I was a backend developer before transitioning to the front end. When when I was building a lot of APIs or a lot of services, I basically just sit down with the front-end developers for like 1 day, and I do whatever I want at the end. Later on, they can be built, they might even be 90% true, and I'll be like, guys, man, that thing is not semantic enough. I want to change it to version 2 now. And they'll be the ones forced to actually implement all those stuff. So what are the bullet points I was trying to make as a problem? We have our foreign clients, we have our tech trends, and we have our multiple network requests. Okay. For our foreign clients, Sarah Drasner actually proposed a comparison called the burger comparison. But because I'm in Nigeria, I changed it to the jollof comparison. Again. So is Ibrahim here? Ibrahim, the last speaker, is not here. Okay, that's good. So I'm going to create this analogy. Imagine you're in a Senegalese restaurant. And let's call the restaurant Restaurant, okay. You go to the restaurant with your friend, I go with Ibrahim, and because he's a Senegalese, he likes Senegalese jollof rice. He goes and tells them, okay, I want the usual. And they give him the initial picture, the picture on top. And you, because you're Nigerian, you'll be like, I can't be eating Senegalese jollof rice now. But they'll be like, sorry, all we have is the usual. And you're forced to actually eat what he eats. But he likes it because it was meant for him. But you as the new guy, obviously you feel like a foreigner because there's no Nigerian jollof rice for you. But what GraphQL presents is a way of telling the waiter that, okay, I'm a Nigerian, I need dodo, I need chicken, I need plantain. And it gives you exactly what you want, as you can see on the next picture. Next point, tech trends. Basically, are you guys still up? Okay, thank you. For tech trends, we have our single-page applications, which is like the trend going up now. How many of you work for companies that are building SPAs right now? Or are building SPAs? Are you serious? Wow. Okay, that's good. We are still on top, no problem. So SPAs are basically using a front-end framework like Angular, like React.js, like Vue, to directly communicate with your clients without necessarily loading the whole web browser. So you are doing all your communication, your whole app works without actually necessarily reloading your whole web page. So you are basically communicating with your backend using Ajax, your asynchronous JavaScript, blah, blah, blah request. Okay. So because of that, a lot of people now realize that if my app is going to have a single entry point, why do I now have to create multiple endpoints at the end just to communicate back to my server? So when I say people, I mean Facebook. They realize that, okay, I need a way to be able to tell my server exactly what I need from a single endpoint. So, and that's when they came up with the GraphQL technology, which is basically a spec. It can be built on both HTTP, HTTPS, or socket ION, or socket, sorry. We have our multiple requests problem, where we have, for our REST example, we have, when you need various data, you have to do a lot of back and forth. You have to send for your users' data, then when they get the ID, you now say, okay, for all the IDs for this user, let me get the followers of this user. When you get the followers, you're like, okay, let me get the images of these followers, and blah, blah, blah. You just keep going like that. So, but for GraphQL, you can actually, from one endpoint and from one request, tell the server that, okay, for this user, I need all his friends, okay, or I need 10 friends from him. And from that friends, I only need their images. So you can actually declaratively tell the backend service what you need, and it will give that to you. So hope you're following, guys. Thank you. So I used my Twitter, and hope you can't see my followers. I should have scraped that off, sorry. Okay, basically your initial Twitter load, you can see that the screen is a bit sparse. You can see they do something, they prioritize some network requests. So the initial network request makes for your post. It makes a GET request for your post. So you can see my post coming in. Then it now has to make another request for my suggested followers or who to follow, as you can see in the next screen, and the trending topics. So from that, if you are going to open your network tab, you guys can experiment it later. You see a lot of network requests to separate APIs for just that page to finish loading. A typical GraphQL, if you can, hope it's not too small, it's not too blurred. If you can see from the top, you can see the way I shaped my query. They basically look in a way like JSON, but they are not, because you don't have the commas. So I asked for a user, and I said I need the ID, a user where the ID is whatever I passed in. Then what I want from the server is what I tell it in the next object. I tell it I need the name, I need the post of that user, and in that post I only need the title of that user. And I also need the followers of that user. I just need the last 3 followers, and I need the name of those followers. And you can see in the response where I get the data, the user, the name of that user, just a single post that the user has written, and the followers of that user with just the name. If peradventure I was to pass the ID, I also get the ID also. Core concepts of GraphQL. We have our schemas, our queries, our mutations, and our subscriptions. Our schemas are what they call our schema, is also called schema definition language. In a way, it's a way of describing the type of data we have on our server. So our front-end developers or our client knows that, okay, these are what is available to me, and I can manipulate it in any way I want. For our queries, mutations, and subscriptions, we can describe it in a way as, for queries, they are your GET requests when you are trying to compare it with your REST endpoints. They are your GET requests. Your mutations are your push requests. Your subscriptions are also your push requests, but they come in events. But I'll go deeper into that now. For our schemas, we have our schema definition language. You can see from what I have a GraphQL object type. This is a custom way of me defining what I have on my database or what I have on my server. So I'm describing now that, okay, all I have on my server is an object named person, and in that object, I have the ID of that person, the name, the age, and the post. This is basically everything on my database. I'm telling you now that this is what is on my database. I'm trying to tell the client that this is all I have on my database. You can't get more than this. For the post, I'm telling them that I only have the title and the author of that. That's all I have. So now we have our scalar types or our keyword types in GraphQL, where we have our queries, our mutations, and our subscriptions. For our queries, as I said before, they are GET requests, where we make a GET request to something called all persons to return a list of the persons. And you can see it's somewhat familiar because you have an array of person. So it returns an array of that person object that we defined at the top here. So for mutation, we say, I'm going to create a function called createPerson. This function is going to be recognized by the server and resolved for you. So we're saying we're only passing in the name and the age of that person, and we are defining the types. That's our string and our integer. And we are saying when it's successful, it should return that exact same thing to me. Hope you are still, I'm still going, right? Okay. For subscriptions, they are basically the same thing as your mutations in a way, but right now we are subscribing to an event that takes place on the server. We are basically saying that anytime a new person is created, probably right now I'm the developer working on the web platform. I'm now saying that if peradventure on the mobile platform someone was to create a new user, I want to be notified. And I want to be given the data of that user so I can actually update my own point. So you can see where you get, in a way, without even using Socket or IO, you get a real-time kind of communication between your services. For queries, you can see I shape my query using all person, name, age, the post of that person. That means the post that person has written, the title, and I'm now telling you that, okay, I only need the title of that post. I don't need anything more. I don't even need the ID. And we get a response back, and this is the exciting part. If you can see, the shape in which you send the request is the shape in which you get the response back. So we are not asking our backend guys, guys, how far now? You change this thing from object to array. You'll be like, man, now yesterday night, one bug just entered, and I had to change it. You get? So immediately they define it in your schema definition language. That is exactly how you get it. There's no unpredictability. And that even enables the front-end team and the back-end team to even build in parallel. Immediately they define their schemas. For our mutations, I created a createPerson function, and I said for name, I want the name to be Bob, and I want the age to be 36. And I said if it's successful, it should return the name and the age of that person, nothing more. If it was to fail, it would return an error, and there's a shape for an error. But right now, if it's successful, it sends the name and the age. So, and I get a response in exactly the same shape as I sent it. I get the name Bob and the age 36. For subscriptions, kind of the same thing. But right now, I'm telling the server that anytime whatever external client or services creates a new user, I want the name and the age of that user. So anytime that happens, I get it in the form of multiple events. It can happen 10 times in a second, and I just keep getting the name and the age of every new user that was created on the server. So how to get started? Obviously, we have to create our virtual environment, even though you burn your system. We activate the virtual environment. We install Django, Graphene. Graphene is the library we use for GraphQL. We don't actually do this from scratch. The technology has been around for a while, so they've already abstracted all those things from us, and that's why I can actually talk about it now. We start our Django project, and we run the server. So I'm going to do a quick demo. Hopefully, my village people will not come and do something. Not win today. Okay. So I'm going to create a scenario that I'm a front-end developer that was given a job recently, and I have no idea what the backend has. And, okay, I need to talk about this. What I'm using right here is what they call a graphical editor. It's built on top GraphQL to expose whatever schema that you've defined on your server. It's like a playground for your front-end developers. So they can just come and try different things. Even though they have no idea what is on the server, you have intelligence that tells you this is what you can do and this is what you can't do. So we know how to do intelligence control, space, or whatever. So I do that, and it tells me I can make a query. I click on query. I open the object. I press my intelligence again, and I see I can query for a person, I can query for all persons, I can query for a post. Yeah. So my backup plan is just to show you how to get started in Django. So when our Django server is running, let's assume we have a models called person. We import the Graphene library, we import the Graphene Django, and we import a Django object type. Then we create a class called person type, and we inherit the Django object type class. Then in our class meta, because I think this is familiar if you use Django REST framework, you see a class meta, and you attach your person model to the models. Then we create a query class, and we assign the graphene.object type, and we say a person is equal to graphene.list. So whenever we query for all persons on the client, which I was supposed to show you, but unfortunately, it returns a list of persons, of your person type, which is already inherited from your model. So you can see how it's actually connected from your database. Whatever you have as your defined model, no matter how plenty it is, immediately you inherit it into your GraphQL model. On your client side, you have the IntelliSense to tell you that, okay, I have the name, I have the ID, I have the post. Even the relationships are shown on the graphical library. So we have a function called resolve persons, which I was talking about as our resolvers. So whatever query you make on your client, you have your resolvers that handle it. And your resolver is basically a normal familiar Django function that you can see, which returns the objects of all. I'm just telling you that, okay, I'm returning all my data to you if you query from the person's list. A simple query, we inherit. Okay, the important part is where we are defining our schema, we attach the graphene.schema, and the query class, where we created our query, we import it and attach it to our graphene schema. So we are telling graphene that, okay, this is our schema that we have. So a simple query, we attach in our part, we attach our GraphQL endpoint, which is only one endpoint. So you can see the benefits GraphQL actually presents over REST. We only have one endpoint in which you can actually do all our communication with our clients with. So this is how the editor was supposed to look like, but you guys could not see it, unfortunately. So thank you. The code is actually hosted on GitHub for you guys to play with it. I'm sorry.